Okay, so now it's time for us to build our schema registry client. All right. So again, will be based on the Confluent Kafka documentation. So make sure, I think for now, as of now, you already know how to consult this based on the producer and the consumer example that have been working. It's basically the same thing. Anytime you need a reference to a method, what are the expected parameters, you can come here on the Confluent Kafka API documentation and look for the class we're talking about. And we're going to basically look today into the schema registry client, also the schema and the schema reference. Okay, so we're going to build our wrapper based on those, and then we're going to use this wrapper later. We're going to create a producer and a consumer using both the schema registry wrapper and the producer and the consumer wrapper that we have. So we're able to put all together. All right. So here on wrappers, let's go ahead and create the schema registry wrapper. And first thing you're going to do, import our libraries. Import login. We're going to also import a couple of stuff from typing. And union. We're also going to import JSON. And the classes from Confluent Kafka. Schema registry, registry client, schema, and the schema reference. We're also going to import error. So we can do our exceptions. We're setting up our login, so I'm going to copy it from the producer wrapper. Okay, that's because that's basically the same thing. I don't want to retype this every time. Okay, so let's go ahead and create our class schema registry admin. All right. So again, if you're straight from to this video and you didn't follow up with the previous classes, just think of the schema registry as your contract database. So you register your schema, gets back a schema ID, and the client's going to embed those IDs in data so the readers can fetch the exact writer schema. Okay, so this is basically what we're trying to do. And we're going to go ahead and define our constructor. And we're going to pass here as a string our path to our schema registry. In our case, is 8082, but we can override this depending on the application side. Okay, so we're just gonna initialize the schema registry client in the constructor. We're expecting as an argument the host URL of the schema registry API, and it's not returning anything. Okay, we're gonna create this single client that I can reuse for all of the other operations that I might have. And 8082, because in Docker Compose we're exposing the 8082 on the host and 8081 in the container, so that's why we're putting 8082 here. So basically we have self URL, and also let's create a client to be the schema registry client, where we're passing as parameter our URL. And let's just log this schema registry initialize at URL. All right. So now we're gonna create a method that we call build schema. This is just for us to create a schema object given a type. So it can be like a JSON, can be an arrow, can be a protobuf. So we're gonna be able to play with that. All right. So let's build those schema builders as a static method. build schema. And here's what I have. We want first the schema string. So the schema definition as a string. So the first thing, schema string. Second thing that we want is the schema type as a string as well. So it can be one of like Avro, JSON, or protobuf. Okay. So let's get the schema type. And we're also going to add a parameter here named references, which will be optional. Those are just optional reference schema in case we want to import or include across files or other modules. If you want to have any reference schema that we have and we want to reuse it. Okay, so let's call it references. And this will be an optional, that's not mandatory, a list of type schema reference. That's why we're importing this. And this is equals to none. Okay, and it will return a type of schema here. That's why we imported those three right there on the top. Okay, so basically this is going to return a schema instance of the schema registry from Confluent Kafka that is just ready for us to register there. All right. We want to make sure that the schema type that is passed are not case sensitive. So I make sure I have, let's convert it, the schema type, to be all uppercase. Okay. So the first thing we're gonna do is like, if the schema type is equals to Avro, we're asking the user, we're gonna try to load this. Okay. If we have an error in the decoding, we're gonna raise this value error, and I'm gonna say, hey, this is invalid Avro schema. I'm gonna print the error. Okay. Otherwise, if it's all good, we're gonna just return the schema from the schema string that I just passed, where the schema type is going to be Avro, and the references is going to be either references if the user sends something, or an empty list in case the user does not want to do anything. Make sure you understand that both Avro and JSON schemas are JSON documents. So we validate the JSON here in case any bad input fails early. Okay. Protobuf though is not JSON, so we're gonna pass the protobuf content as it is. All right. Now, in case we have JSON, or we can also accept JSON schema, we're gonna try the same thing. JSON.loads schema string. We can have an exception. JSON decode error, and we're gonna raise an exception, an invalid error here. Invalid JSON schema. Let's print this. All right. Otherwise, if everything looks good for us, we're gonna return the schema where the type is going to be JSON, and references can be the references or nothing. All right. Now, if the user sends protobuf or proto, which is also common, protobuf is not JSON, just like I mentioned. So we're not doing JSON.loads here. We're just returning the schema. Schema type will be protobuf. And we have the references. References are null. Now, if the user doesn't send any of those options, if we don't pass any of the options, we're just gonna raise a value error here to say that unsupported schema type. And let's capture what was passed. Please use arrow JSON or protobuf. Okay, so we do have our constructor to initiate our client and the build schema, which are basically returning an instance of the schema class from Confluent Kafka based on what the schema type that the user has inserted. Okay, so let's create one more. Let's create one method for us to list subjects. So basically, this is going to list all of the subjects' names that are known to the registry, and we're just going to return a list of the subject names. Okay, so this should be quite simple. We can do list subjects and just return a list of string. All right, so we can use the method get subjects from the Schema Registry client that you can find the documentation. So you can do a try, and let's get subjects as the client get subjects. Okay, we can log that. Subjects found, then we can do subs and return it. Otherwise, if we get any error except from the Schema Registry, we can log that as well and say failed to list subjects. Let's see this error, and then we'll return nothing. Let's return an empty string. Okay, so let's stop here. I think the video is too big, and let's continue on the next one.